Okay, so since you seem to be getting everything else, let's just concentrate on these p-values. Now, hypotheses tests are a little bit trickier than our confidence intervals because if we have a population that is normally distributed and we know sigma, which is very rare, and we do know sigma here, we know the population standard deviation, we can use our z-score, our normal or standard normal distribution. So we are here going to use the standard normal distribution instead of the t distribution. So remember, if you are told that the population is normally distributed and you know what the population standard deviation is, not S, but sigma, then you can go to the standard normal distribution. So we're going to do that here. We're going to put 1.692 into the standard normal distribution. Oh, I think I'm already opened here. Equal norm.s.dist 1.692 and true. And I get that. Now, we're not done because what we have as our p-value is determined by the alternate hypothesis. If my alternate hypothesis is a less than hypothesis, or a less than, if it looks like this, then this is my p-value, which would be a very huge p-value. P-values tend to be small. If it's close to 1, generally that's kind of a clue that we may have made a mistake. No, we've not made a mistake though, because our alternate hypothesis is actually a greater than. And since it's a greater than, we always subtract from 1 whatever we got out of Excel. So our p-value, whoops, is equal 1 minus 0.954677, 0.045323. I think it said around to 4 decimal places, so 0.0453. And that, of course, is what the answer is there. Okay, now let's grab another just to make sure you're that one's also greater than. So notice normally distributed, you have your sigma, so you're going to use that normal, the norm.s.dist. And is this one greater than? Yeah, those are all greater than, so greater than. Okay, yeah, so let's see, here's a not equal to, so let's take a look at that one. All right. Um, so you got 2.192. Let me write that down real quick so I don't lose it between screens. Find a pencil. 2.912. 2.192. Okay, so going back to Excel, equal norm.s.dist 2.192, true, and I get 0.98581. Or let's go ahead and round it to 4 decimal places, 0.9858. Okay, now, before, let me draw a picture here for a second to help with this one. So when we have a not equal to, we have a two-tailed distribution, and our rejection region is here and here. Now, when we put in the 2.192, it gave us all of the stuff over here. Okay, so what we want to do is we need to first figure out what this little piece is here, because we're getting all of the probability over to the left, because 2.192 is right here to the right of 0. Remember, on our standard normal curve, 0 is here. So first, let's subtract the 0.9858 from 1, and that's going to give us this little region here. But notice there's two symmetric regions in a two-tailed distribution. So we've got to subtract 1 minus 0.9858, and then once we do that, we're going to double it for the two regions to get the p-value. That will give us the probability in both regions. So this is 0.0142, and then of course if we double it, it ends up being 0.0284, and that is our p-value for that particular one. All right, so sort of some rules of thumb here. Let's see if I can type them for you on a new page. So if the alternate is less than, just look up your p-value. And that's the answer. That's the p-value. So less than is always nice. If the alternate is greater than, look up the Excel value and subtract from 1. If the alternate is not equal to, let's see, not equal to is not as easy for me to pull up. Here it is not equal to, then if the test statistic, sorry, my dog is making all kinds of noise in the background. If the test statistic is positive, subtract, or well, look up the Excel value. Subtract from 1 and double it. And if the alternate is not equal to again, and then if the test statistic is negative, look up the Excel value, then double it. All right, so that kind of gives you all the alternatives. Now, if we have a small sample size and we're not told that it's a normal distribution, and we don't have sigma, then we're going to use that t distribution. That would be the only difference. As far as all of these steps, it will still be the same. So hopefully that will help dispel a little bit of your struggles there.